Good morning, students. In the last class, I have discussed about the molecular size of olive oil. Today, in this class, at first I will discuss one numerical problem related with this olive oil, related with the theory actually. So, the numerical problem, it is already written in the board. Let's see what is given. A drop of olive oil of radius 0.25 millimeter spreads into circular film of radius 10 centimeter on the water surface. Estimate the molecular size of olive oil. So what is actually given in this question? A drop of olive oil, it is given on the water surface, and due to which it spreads and creates actually a circular thin film. Now here what are the given data? The radius of the drop of the olive oil, it is given. Means here radius of drop of olive oil, it is given. What is it? 0.25 millimeter. And another data, what is given here? Spreads into circular film of radius 10 centimeter. Means after dropping the olive oil when it spreads, it creates a circular thin film and the radius of that circular thin film, it is given. What is it? It is given 10 centimeter. So radius of the circular thin film, radius of the circular thin film, it is given. Circular thin film, it is given what? 10 centimeter. So these are the given data in this numerical problem. And estimate the molecular size of the olive oil. In that theory already I have said one thing that the thickness of the thin film is equal to the diameter of one molecule of the olive oil. That means molecular size of the olive oil thickness is same. So regarding that concept, actually we have to solve this numerical problem. So what will be the here thickness or size of the molecular or size of what is the molecular size of olive oil? To calculate this, we have to find out the thickness of the thin film which is created on the water surface. So we will write here thickness of the olive oil. Thickness of the oil film. Thickness of the oil film. What is it? It is equal to the volume of the olive oil. Volume of the oil drop. Volume of the oil drop divided by area of the film. So area of the film. Now volume of the oil drop, actually the oil drop is considered as a sphere. That is why here radius is given. Radius of the drop of the olive oil, it is given. If we know the radius, then what will be the volume of the sphere? It will be 4/3 pi r cube. So we will write here 4/3 pi into r cube. R is what here? 0.25 millimeter. So we will convert this data to centimeter first. So if we convert millimeter to centimeter, what will be the result? Actually here 0.025 centimeter 4/3 pi r cube, whole cube. This is cube divided by area of the film. radius of the circular thin field is 10 centimeter. So what will be the area of the film? It will be pi r square. So pi into r is what here? 10 centimeter. So 10 centimeter square. 10 centimeter square. It is 10 centimeter square. So if we simplify this numerical problem, what will be the result actually here? So now we can rub this thing. So 4 by 3 into pi into 25 whole cube. If we write this thing in tens power, 10 to the power minus 3 into 10 to the power minus 3 whole cube, 10 to the power minus 3 whole cube divided by pi into 10 square, and result will, the unit of the result will come in centimeter. So what will we get? We will get pi cancel. So 4 by 3, 25 centimeter cube. It will be 9. So 10 to the power minus 11 centimeter. 11 centimeter. So if we simplify this thing, we will get the result in this way. This is equal to 2.08 into 10 to the power minus 7 centimeter. Actually here I have written the result directly from this part to this. Simplification part you can do yourself. You simplify yourself and match the result whether it is you have got or not. So actually here result will be this one, and this is the numerical problem and nothing. And I think you are more clear how actually we can solve this such type of numerical problem. And after that I will discuss about some theory. So in our today's class, so at first the theory is, I will start about the definition of mass. Actually mass already you have you know what is actually mass. I will again describe about the definition of mass here to again. So let me discuss. Mass means actually the amount of substance contained in a body, and the mass of the body is the basic property. It is the basic property, and it does not depend upon the pressure, temperature, or the space, or the actually location in which place actually the body is kept. Mass is independent of that mass is actually independent of temperature, pressure, or location. And the SI unit of mass is kilogram, and CGS unit of mass is gram. So about mass, these are the main things which you should know. And after mass I will discuss about the terms weight. Actually weight, so weight though actually mass and weight, those are not same, those are different thing. Mass is actually independent of the location, or independent of the where actually we have kept the body, independent of that thing. But weight is dependent on the location where we have kept the body. because weight means the amount of attraction force by which the earth amount of attraction force exerted on the body by the earth actually. That means with which force the body is pulled towards the center of the earth, the weight is dependent upon that thing. So weight is not independent of the location where we have kept the body, and weight is expressed in this way. W equal to m into z. Means weight to tarmane body to ami kontu locationot rakhisu tare oporot weight to dependent hoy, kintu মাছটো আমি বডিটো কোনটো লোকেশ্যনত ৰাখিছোঁ তাৰে ওপৰত ডিপেণ্ডেণ্ট নহয়। এইটো এটা মানে ভাষ্ট ডিফাৰেঞ্চ হয় মাছ আৰু ৱেইটৰ। চ' দ্য ৱেইট ইজ একচুৱেলি এক্সপ্ৰেছড ইন দিছ ৱে, W ইকুৱেল টু m ইনটু z, where z is the gravitational acceleration, or it is also said in this way gravity. And gravity actually changes from place to place, and the SI unit of weight is Newton. SI unit of weight is Newton, whereas the SI unit of mass is kg. So this is the main actually difference between mass and weight. Mass is variable, mass is constant, but weight is variable. It depend upon the location where we have kept the body. So about mass and weight, these are the main thing. After that I will discuss about the topic measurement of time. So at first I will discuss about measurement of time. All of we know to measure the time a clock is very required. So according to actually Einstein, time is simply what a clock reads. Time is simply we can define time in this way, that time is simply what a clock reads. Any phenomenon which repeats after equal interval of time can be used as a time standard. For example, যিকোনো এটা ফেনোমেনন, যিটো ফেনোমেনন এটা ইকুৱেল ইণ্টাৰভেলৰ মূৰে মূৰে ঘটি থাকে, তেনেকুৱা এটা আমি ফেনোমেননক আচলতে টাইম ষ্টেণ্ডাৰ্ড হিচাপে ইউজ কৰিব পাৰোঁ। ফৰ এক্সাম্পল, নম্বৰ 1, বিটিং অফ হিউমেন হাৰ্ট। Number 2, oscillation of a pendulum. So beating of human heart and oscillation of a pendulum, both the phenomenons are occurred after a equal interval of time. So such type of phenomenons are we can used as a time standard. And nothing. And after that I will discuss about some techniques which is used for measuring time interval. To measure the time interval, what are the actually techniques we can use? I'll discuss about this thing. Let's see. So techniques to measure, what are the techniques? First technique, quartz clocks. Actually in this clock, quartz, one kind of crystal, quartz, the name is quartz. This crystal is used to develop oscillatory EMF, and these oscillations is used to oscillatory EMF, and this oscillation is used to measure the time interval. And this is nothing. Here actually in this clock, quartz crystal is used. And another clock which is called the cesium atomic clocks. Cesium atomic clock, cesium atomic clock. In this cesium atomic clock, it is actually dependent on the periodic vibration which is occurred inside the atom, cesium atom. Periodic vibration is occurred inside the or within the atoms, and this clock is depend upon that vibration and nothing. Cesium atom. So this is another kind of cesium atomic clock, and another there is a method. These are the clocks actually with the help of which we can measure the time interval. And another technique to measure the time interval, which is called the radioactive decay. Radioactive decay. So what is it actually? Radioactive decay. So radioactive decay. This is another technique to measure the time interval. With the help of this technique actually we can measure the long interval. Whereas a clock actually cannot help. With the help of clock actually a long interval we cannot measure. In that case we have to use this technique, radioactive decay. So in radioactive decay actually, how we can measure the long interval? For this we have to find the ratio of the number of radioactive atoms, we can write in this way: ratio number of radioactive atoms, number of radioactive atoms which undergo have undergone decay to the number of atoms that left undecayed. So what is it actually? How the long interval we can measure with the help of radioactive decay. For this we have to know the number of atoms, ratio of the number of radioactive atoms that have undergone decay to the number of atoms left undecayed. That means what? Kisuman enekwa atoms ase jibilak atoms actually মানে নিজে নিজে ডিকে হয়, ক্ষয় হৈ যায়. চ' আমি বহুত বছৰৰ মূৰত আমি সেই ৰেচিঅ'টো ওলাব লাগিব. এটা এটম বা আমি যিটো ছাবষ্টেঞ্চ লৈছোঁ সেই ছাবষ্টেঞ্চটোৰ কিমানটা এটম একচুৱেলি ডিকে হৈছে আৰু কিমানটা এটম ডিকে নোহোৱাকৈ আছে, আমি সেইটো যদি মেজাৰমেণ্টটো লওঁ আৰু সিহঁত দুটাৰ যদি আমি ৰেচিঅ'টো ল'ব পাৰোঁ, তেতিয়াহ'লে সেই ৰেচিঅ'টোৱে আচলতে আমাক কি দিব, কিমান দিনৰ মূৰত সেই ইনচিডেণ্ট বা সেই ফেক্টটো ঘটিছে সেই টাইমটো আমি মেজাৰ কৰিব পাৰিম. Actually, this process is applicable only in case of radioactive atoms only. Means what? All the atoms do not decay itself. Some kinds of atoms means there are some kinds of substances which can decay itself. Those are called radioactive substance. Only in that case only in case of radioactive substance only we can apply this method, radioactive decay. For example, carbon dating, and also another uranium decay. Uranium also uranium's molecule is decayed and carbon is also decayed. So uranium decay, it is used to measure the age of the rock actually. Rock এটা মানে শিল এটা কিমান দীঘলীয়া বা কিমান পুৰণা কেনেকৈ ফৰ্ম হৈছে এই গোটেই টাৰ্ম মানে সেই ডিউৰেশ্যনটো আমি মেজাৰ কৰিব পাৰোঁ উইথ দি হেল্প অফ ইউৰেনিয়াম ডিকে. So by actually calculating the ratio of the number of radioactive atoms which have undergone decay, কিমান কেইটা এটম ডিকে হৈছে তাৰ সেইটো আৰু number of atoms left undecayed আৰু কিমান কেইটা এটম ডিকে হোৱা নাই সেই দুইটা ৰেচিঅ' ওলাই পেলাই আমি সেই ডিউৰেশ্যনটো আমি ৰেডিঅ'এক্টিভ ডিকে এটমৰ ক্ষেত্ৰত উলিয়াব পাৰোঁ. So in this way radioactive decay, with the help of radioactive decay actually we can measure the long term duration where actually the clock does not or cannot help us. ক্লকটোৱে আমাক হেল্প কৰিব নোৱাৰে, আমি লং ডিউৰেশ্যন মেজাৰ কৰাৰ কাৰণে ক্লকটোৱে হেল্প কৰিব নোৱাৰে. ইন ডেট কেছ উই হেভ টু এপ্লাই অৰ উই হেভ টু টেক হেল্প অফ দিছ মেথড ৰেডিঅ'এক্টিভ ডিকে এণ্ড নাথিং. So let me discuss what is actually 7 dimension of the world actually. Actually what all the derived physical quantity can be expressed in terms of some basic or fundamental quantity, and those are the actually called the dimension of the world. There are 7 such kind of 7 fundamental basic quantities, and those are what actually the dimension of length. If we say what is the dimension of length, then we have to express in this way. Capital L, dimension of length is expressed in this way, capital L. And the block symbol we should give this thing. And dimension of mass, it is written in this way, capital M. And dimension of time, it is written capital T. Then dimension of electric current, it is written in this way, capital A, whereas dimension of thermodynamic temperature, it is Kelvin, and it is symbolically capital K. And dimension of luminous intensity, candela, CD. And dimension of amount of substance, it is mole, and written in this way. So after getting this fundamental or basic quantities, dimension of this basic quantity, let me find out the dimension of density. For example, how we can find out the dimension of density, let me discuss. So dimension of density, dimension of density. So density, all of we know what is actually density. Density is nothing, the ratio of mass and volume. So density we can write in this way, mass per volume, mass per volume. So volume, actually volume is the derived quantity. So if we express this volume in fundamental or basic quantity, how can we write? Volume is equal to length into breadth into height. So this is mass divided by length into breadth into height. into height. So what is the dimension of mass actually? So dimension of mass we can write symbolically in this way. Capital M divided by length, capital L, we should give this actually block symbol, into breadth means actually this is also L, this is also L, and height this is also L. So what will be the actually result? Density, the dimension of density we can write here also, M L to the power minus 3 we can write here, and here actually M L to the power minus 3 t to the power 0 we can express in this way. T to the power 0 means time dimension is not actually utilized here, that is why we write here there is no dimension 0, and M mass actually m to the power 1 and L to the power minus 3. So MLT utilizing or using this basic quantity or basic dimension we can express the dimension of density in this way. So I think you are clear, actually more clear how we can express the dimension of derived quantity with the help of basic quantity. We can discuss many more examples, and then you will be more clear. In the next class I will discuss another some dimension of derived quantity. Today I will stop here, and I think you are clear, and I will send you the notes, and if you have any confusion or doubt you can ask me through message. Just study the notes clearly and try to understand, and nothing. So thank you here today.